Good morning students, I welcome you all for another lecture on the course Computer Architecture and Organization. In the last class, we discussed about the synchronous bus protocol or synchronous bus. In today's class, I am going to discuss about the concept asynchronous bus or asynchronous bus protocol. Right. So in case of this asynchronous data transfer or asynchronous bus protocol, the data transfers on the bus was controlled by handshake between the master and the slave. In case of synchronous bus or synchronous protocol, the data transferring was going on the bus with reference to a clock signal. But coming to this asynchronous case, the data transfer is going on between a master and a slave with the help of handshaking signals or simply handshake signals. With the help of handshake signals, we can do data transfer between a master and a slave in case of asynchronous data transfer or asynchronous bus protocol. Right. The common clock in the synchronous bus case is replaced by two timing control lines. One is master ready and second one is slave ready. That's what I'm saying. In case of synchronous, the data transfer is controlled by a clock signal. But coming to asynchronous bus or asynchronous bus protocol, the data transfer was controlled by two control signals. Both are handshaking signals. One is master ready and second one is slave ready. What these are two signals are? The first one, what a master signal is. The master ready signal is asserted by or activated by the master to indicate that the master is ready to participate in the data transfer. It means when a master activates this, it is very clear guys, it is a master ready signal. That means this signal is only activated by the master. The master in the sense, the device who initiates the data transfer over the bus, that device we consider as a master. So here the master ready signal, which is one of the handshaking signal in case of this asynchronous bus. This signal can be activated by only the master. The indication of that one is the master is ready to participate in data transfer. So that is this master ready signal. And similarly, the slave ready signal. What is the slave ready signal is? Generally, the slave ready signal is activated or accented by the slave in response to the master ready. I repeat, this slave ready signal is asserted or activated by the slave in response to the master ready. That means generally this slave ready signal is activated by the slave in response to the master. It means it indicates to the master that the slave is ready to participate in data transfer. So master ready indicates the master is ready to participating in data transfer. In a similar way, the slave ready control signal is indicates to the master that the slave is ready to participating in data transfer. So both the master ready and the slave ready, both are the handshaking signals. Fine. Data transfer using this handshaking signal protocol. So how we are doing this data transfer? By using these handshaking signals that we are going to discuss. The first step, what we are trying to do is master places address as well as the command information on the bus. So I already told you that what a master means. Master means a device who initiate data transfer on the bus. So in a first time instant, what we are doing is the master places the address and command information on the bus. That means your master want to communicating with which slave. The corresponding slave address the master places on the bus as well as the master want to do which type of operation on the slave. That means your master going to read something from the slave or the master going to write or master going to send something to the slave. So that it can be transferred to the slave in terms of command information. So the first thing what we are doing in case of this particular data transfer is The first thing is the master places the address and command information on the bus. This is the first thing. And next one, after places these are two things, master ready signal is activated by master to indicate to the slaves that the address and command information has been placed on the bus. Once your master places address and command information on the bus, immediately what a master can do is, it will activate master ready signal, which is one of the handshaking signal. Once that signal can be received by all the slaves which are connected to the bus, or the devices which are connected to the bus, those devices identify that the master already sent an address information as well as command information over the bus. So all the devices which are connected to the bus, they go and accept that address and they try to decode that address. That address belongs to which device. So the second thing what happens is, the master assets or activates master ready signal to indicate to the slaves that the address and command information has been placed on the bus. And third thing, all the devices on the bus decode the address what a master places on the bus. That is absolutely, because once the address was decoded by the devices, they identify that which is the device our master want to communicate. So the third thing is, all the devices on the bus decode the address. And coming to the fourth, the addressed slave performs the required operation and informs the master it has done so by asserting the slave ready signal. So here the thing is, once address was decoded by the device and a corresponding slave, it has to perform what is the task that can be given by the master in terms of command information to the corresponding slave. Once it performs the task, then what the slave can do is, it will activate slave ready signal. That means it will inform the master that I did whatever the task that was assigned to me. So that was indicated by this. Next, a master removes all the signals from the bus once slave ready is asserted. So here what happens, once a slave activates a slave ready signal, once that can be identified the master have a clear cut idea about the task what I assigned to the slave, it was finished. So that what the immediate master can do is, it removes all the signals. That means your master removes the address information as well as command information from the bus. So that is the meaning of this. Master removes all the signals. Here all the signals in the sense, address information as well as and command information. These are two signals, two types of information of signals can be removed by the master from the bus once a slave ready signal is asserted or activated. That means the operation on the bus was finished between a master and a slave. In this entire data transfer, here are two control signals. One is master ready and the slave ready plays a vital role. With the help of these two handshaking signals, we perform the data transfer over the bus. In this case, we are not using any clock signal between a master and a slave. So that's why it is asynchronous. Alright. So, and the last one is, if the operation is a read operation, that means, in this case, previous case, what we did is, our operation is something writes. Our operation is right, that's why the information that is placed on the bus that can be accepted by the device, then the device can go and activate a slave ready signal that informs to the master that I receive what are the data you are sending to me. If the operation is read, that means your master is going to read something from a slave. Then what we are doing here is, if the operation is a read operation, the master also strokes the data into its input buffer. Absolutely. Once your master asking something from a slave, it will generate an address. It will generate a command signal. After that, it will activate a master ready signal. So by sending up these things to the slave devices, once the corresponding slave was respond for the command as well as address information what is issued by the master, the slave send the data to the master with the help of bus. That means a slave places data over the bus that can be received by the master. Once it places the data over the what a slave can do is it simply activates a slave ready signal that indicates to the master that I did what was the task that was assigned to me. So if that is a read operation, then again what your master can do is, once your master successfully took the data from a data bus, it stores that information. That means whatever the data that was placed on the bus that is accepted by the master, it simply put that data into its input buffer register. That instead, what a master can do is it will store that information. That means it gives the confirmation, yes, I successfully received the data, what you are sending to me. So this is a simple timing diagram to do this entire data operation. See here guys, in this particular T0 case, in a T0 case, the master sends an address as well as command information. After certain amount of time, your master activates a master ready signal. This master ready signal gives the indication to all the devices which are connected to the bus about the master place some address as well as command information on the bus. Then what those devices can do is they are going to accept that information and they decode the address and they can identify what the command or what is the information that will be transferred to the corresponding device by the master. Those things are identified by the devices. Later those devices send the information to the master as well as they go and accept the data from the master. So here, once your slave successfully performs what are the tasks that can be done by a slave, it activates this slave ready signal. At the same time here, one more thing is happened, that is, in this entire operation is related to a read operation. What is the meaning of this read? The master collects some data from slave. That's the meaning of this. Whenever the slave places the data on the bus, at the same time what it does is, it will activate this slave ready signal. See here guys. So slave ready signal activated at this instant, that is a T2. At the same time, the data was placed on the bus. So once your slave places the data on the bus, then your slave can activate a slave ready signal. So once it activates a slave ready signal, then your master identifies that the slave finishes the task what I was assigned to it. So here that's the meaning of this particular timing diagram. So this I discussed in detail with some beautiful steps. In the first step, that is a time instant T0, the master places the address and a read command. That's what I'm saying. So just now here we assume that the read command belongs to the memory. That means here you assume that your master is a processor and the slave is a memory. So in a time instant T0, the master places the address as well as the read command information on the bus. So once it places an address as well as command information on the bus, immediately in a T1 time incident, the master activates or assets master ready signal. This signal asserted T1 instead of T0 to allow bus Q. Here important thing is if I am not activating my master ready signal at a T0 incident, I am activating this master ready signal in T1 time incident because to allow bus Q. What is this bus Q is? The bus Q occurs when two signals are transmitted simultaneously reach the destination at different times. That means if I transfer two information on the bus, they simultaneously carries two information on the bus, but these two information can't reaches the destination at the same time incident. They are received by the destination in different time incidents. Why? The reason for this is the speeds of these buses are not same. These buses speeds are different. That's why these signals are reached to the destination in different time incidents. This is what we can call is a bus queue. That is an important one. Next, this may occur because different bus lines may have different speeds. Right? So because of that, there is a chance of existence of bus queue. So in T0 time incident, the master places address as well as command information on the bus. In T1 time incident, the master activates master ready signal. Why the master ready signal was not activated in T0? The reason for this is to allow the bus queue. So what a bus queue is? The bus queue occurs when two signals transmitted simultaneously reach the destination at different times. The reason for this is different lines have different times or different speeds. That's important. Right. Next, the difference between T1 and T0. What the duration is? It is very, very important, friends. That is T1 minus T0 should be greater than maximum skew. Maximum skew. What is the maximum skew? What is the bus skew? We are sending two signals on two different buses. They are traveling simultaneously, but they didn't reach a destination in a same time period. The reason for this is the buses have different speeds. So here this T1 minus T0 must be or should be greater than maximum skew. It should also include the time taken to decode the address information by the slaves or the devices which are connected to the bus. We know that once a master sends an address over the bus, that address can be received by all the devices which are connected to it. Once the address is received by all the devices, those devices take certain amount of time to decode that address. Once they decode that address, they identify that the generated address belongs to which device. This address decoding generally is done by I/O interfacing circuits or I/O modules. We know that from past classes, because we are not directly connecting an I/O devices to the system buses straight away. The reason for this is all the devices' speeds are not same, their speeds are different, their logics are different, so that we are not directly connecting an I/O devices to the system bus. The I/O devices are connected to the system bus with the help of only I/O interface or an I/O module. So here important thing is this T1 minus T0 should be greater than maximum skew, and also includes the time taken to decode the address information. How much time your interfacing circuits take to decode an address? That is also you have to consider to decide a T1 minus a T0 duration. And next in T2, the addressor slave places the data on the bus and sets the slave ready signal. Yes, absolutely, because our operation is a read. Once a slave decode an address, we are sending a command is a read command, so that here our slave was a memory. The memory, once a decode an address, that address belongs to some particular memory location. That memory location data is placed on the bus. Once it places the data over the bus, then what happens is it simply activates slave ready signal. It is another handshaking signal. It may happen in T2 time instead. And next, the period, that is T2 minus T1, depends on the propagation delay between the master and the slave. It is very, very important. So the difference between T2 and minus T1, it is purely depends on the maximum propagation delay between the master and the slave. In the last class, we clearly discussed what the propagation delay over the bus. The propagation delay between the master and the slave is not same for all the cases. Because one device is nearer to the master and some other device which is farther to the master, in both the cases the propagation delay was not same. So here the period T2 minus T1 is purely depends on the propagation delay between the master and the slave and the delay in the slave's interfacing circuits. That's absolutely right. Once your device places a data, the data is not directly goes to the bus. It is first goes to I/O interface, later it goes to bus. Here it is a memory. The memory is going to send the data to the bus. It takes certain amount of time. So that's why here a delay exists. Right. Next, in T3, what happens? In T3, slave ready signal arrives at the master. In T3, the slave ready signal arrives at the master. Once the slave ready signal was placed on the bus, at the same time, the data were placed on the bus. Absolutely. That's what I'm saying. Once your memory places the corresponding location information on the bus, at the same time your memory can activate another handshaking signal, which is a slave ready signal. Once your master identifies or it receives a slave ready signal from a slave end, it identifies that the slave places its data on the bus itself. It can identify that. So here the master should wait for maximum bus queue plus the setup time of its input buffer and then stops the data. So it is absolutely right. Once the data is available on the bus, it will go and gather the data. For that, first of all, it set up its internal buffer register. To set up its internal buffer register, it takes certain amount of time. Once it set up the internal buffer register, later it will grab the data which is available on the bus into input buffer register. Later it will store that information. That means I successfully received the data which is transferred to me from the slave. So that's the meaning of this. So later what it do? It also deactivates the master ready signal to indicate that it has received the data. Yes, absolutely. Once it successfully receives the data from a slave end, the received data is copied onto the safest place in its internal buffer register. Then what a master can do is it simply deactivate master ready signal that indicates to the rest of the devices which are connected to the bus. The master finishes its task. That means your master either receives the data from a selected device or a selected location, or it may transfer the data to the selected device or a selected location. That is then depends on the operation. It may be a read or it may be a write. Here the scenario was a read operation. That's why once it successfully receives the data from the slave end, then what it do is it will deactivate the master ready signal. So that indicates to the rest of the slaves or the devices which are connected to the bus, the master finishes its task. Yes. And next, in T4, what a master can do? The master removes the address as well as the command information from the bus. So once you deactivate your master ready signal, that gives the information to all the devices, that the master finishes the task. In T4, what a master has to do? The master removes whatever the address it places over the bus as well as the command information what it already placed on the bus, it can remove that information. So that it will do in T4. So now the time difference between a T4 and a T3, that is a T4 minus T3, allows for bus queue. Yes, once master ready signal is set to 0, it should reach all the devices before the address and command information is removed from the bus. See, absolutely. So what is the T4 minus T3? It allows bus queue. Because once it deactivates a master ready signal, generally master ready signal is active high signal, there is no bar over this. Once the signal is deactivated, means this is set to 0. So it should reach all the devices. It should reach to all the devices before the address and command information was removed from the bus. It can't immediately remove the information which is placed over the bus. To remove the information over the bus, that may be address information or a command information, it takes a certain amount of time. Because first it will deactivate the master ready signal, later it will go and remove the information what it already placed over the bus. So this is a T4 minus T3 that it indicates. Next, what the T5? So T5, the slave receives the transition of master ready signal from 1 to 0. It removes the data on the slave ready signal from the bus. Absolutely. Once your master send a master ready signal, it deactivates that signal. It sends that information to all the slaves by changing logic level on the master ready signal from 1 to 0. Later, what a master can do in a master side is it go and simply remove the address information as well as the command information what it already placed. Once a slave receives that master ready signal was deactivated, that means the logic level on master ready signal was changing from 1 to 0. Then what a slave can do is my data was successfully received as the master. That's why the master deactivated master ready signal. So what I have to go and do is I can go and remove whatever the data was placed on the data bus or a bus itself, as well as it will go and deactivate a slave ready signal. That it do in time period at T5. Right. So this is how we are doing a data transfer operation in case of asynchronous bus or asynchronous bus protocol. We can go and see what are the advantages as well as the disadvantages of this asynchronous bus. So first we'll see the advantages. Here I would like to find the two advantages. The first advantage is it eliminates the need for a synchronization between the sender and the receiver. Absolutely. That means here we need not be synchronized. That means you need not be apply common clock to both the sender as well as the receiver. In case of synchronous bus or synchronous bus protocol, both the master and the slave or a sender and a receiver must be operated at the same clock. That means both the devices must be synchronized. In case of this, it need not be do that. That's why it eliminates the need for synchronization. So it is an advantage. And the second thing is can accommodate wiring delay automatically using the slave ready signal. Absolutely. That means here we are not bothering about the delays of our devices. So delays of devices, we can accommodate wiring of our delays automatically because here we took the help of handshaking signals. One is a slave ready as well as one is a master ready. For example, the master wants to communicating with a slave. For example, you can assume guys, this is a master and this is a slave 1 and this is a slave 2. This can be operated at some speed S1. This can be operated at speed S2 and this can be operated at speed S1. So here important thing is this master want to communicating with this slave or this slave. Here their speeds are different. Their speeds are different. But I can automatically communicating with these devices. Still if their speeds are different, I didn't face any problem because here I took the help of control signals which are handshaking signals. So whenever this master want to send something to the slave, then this slave was expecting some response from the slave. That means this slave has to send this slave ready signal to the master, then and only this master going to send some information to the corresponding slave. So that's why here important thing is wiring delays automatically uses a slave ready signal. We can accommodate it. If the delays of the devices may differ, we didn't face any problem for this. This is only possible in case of asynchronous bus protocol or asynchronous bus. But it does not exist in case of synchronous bus or synchronous bus protocol. Fine. These are the two major advantages we are getting from this asynchronous bus or asynchronous bus protocol. We can go and see what are the disadvantages. Here we will found two disadvantages. In that the first one is the data transfer rate with a full handshake. That means a handshaking from master end as well as a slave end limited by 2 round trip delays. Once your data transfer was successful between the master and the slave in case of this asynchronous, whenever the data was transferred to the slave from a master, what a master can do is it will activate his master ready signal. It is one of the handshake signal. Once the data was successfully received by the slave, then slave send again one more handshaking signal back to the master. That was a slave ready signal. Here, these are the two handshaking signals and definitely exist in your data transfer. One round trip in the sense, one case your master send an information and later slave send and back information to the master with the help of two handshaking signals. So here, round trip time, that is a 2 round trip delays are exist for this. This is one thing. But in case of synchronous serial communication, only 1 round trip delays exist. Because your master and the slave must be synchronized with the same clock. If a master initiates, it will transfer, it will inform its speed of operation to the slave by sending off a clock pulse. So in that case, your master can't expecting anything from a slave and back. So in case of a synchronous serial communication, your round trip time is only 1 round trip delay. But in case of asynchronous, it is a 2 round trip delays. So here once in a synchronous, only 1 round trip delay was exist so that in case of synchronous bus, the data transfer was achieved at a faster rates. That means the final conclusion is the data transfer rates of asynchronous bus or asynchronous bus protocol is lower compared to synchronous bus protocol or synchronous bus. The reason for this is 2 round trip delays are exist in case of asynchronous, but in case of synchronous, only one round trip delay was exist. So that the speed of operation of a synchronous bus is lower compared to synchronous bus. So these are the disadvantages of this asynchronous bus. With this, we finish asynchronous bus protocol or asynchronous bus. So with this, we finish the buses concept. In previous two classes or in previous class, I discussed about a synchronous bus, and now I discussed about asynchronous bus. I hope you understand the buses concept, right? We discussed first what is a bus and all those things. So in that bus we have an address bus, data bus, control bus, all those things we discuss. And later we are talking about the bus protocols or the buses. First we discussed a synchronous bus. In today's class we are discussing about asynchronous bus. So with this we finish this bus concept. I hope you understand this bus.